In this lesson, we're going to take a look at static and kinetic friction. Remember, frictional forces oppose motion or intended motion. Static friction is the force that keeps an object from beginning to slide, and kinetic friction is the force that opposes motion when two surfaces are sliding past each other. So here's our problem. A 50 kilogram crate just begins sliding when a force of 300 newtons is applied on it. Now, we get some information there. If it just begins sliding, that means it starts to accelerate when the force meets or exceeds 300 newtons. And so we know our static frictional force is going to be less than or equal to 300 newtons. So I'm going to go ahead and write that down. We know Fs has to be less than or equal to 300 newtons. If that force continues to act on it, the 300 Newton force causes an acceleration of 0.3 meters per second. So from that, we're supposed to determine the coefficients of static and kinetic friction. Now, that's not the same thing as the frictional forces, but we're going to have to find the frictional forces in order to get these coefficients. So let's start with the case where it's at rest. It's not accelerating, it's just about to accelerate. We apply a force of 300 newtons, which is exactly balanced by static friction. But if it exceeds that 300 newtons, then we're going to go ahead and start accelerating. So that's why we have Fs is less than or equal to 300 newtons. There's also the force due to gravity pulling down on it, and the normal force which balances it because it is resting on a surface, otherwise there wouldn't be friction. So from this, we are going to solve and get the coefficient of static friction. The only equation we have that involves Fs is Fn mu s equals Fs. And this is where mu s is the coefficient of static friction. So we're going to use this equation. Fn, of course, is going to exactly balance gravity, and since this is a 50 kilogram crate, we know how big that is. Fg is equal to 50 times 9.8, and this is 490 newtons. Now this would be negative or down, and that means our normal force is also 490 newtons, but it's positive or up. So I have 490 times the coefficient of static friction is equal to the static frictional force, which is less than or equal to, so I'm going to switch my sign to less than or equal to 300, and that's newtons. Now that means mu s is less than or equal to 300 divided by 490. Now the reason we get this less than or equal to is, remember, static friction can actually match whatever force we apply up until we break it, up until it starts to slide. Now when we do this math, what we get is 0.612. Now that is a unitless number. It's the ratio of the normal force or the static frictional force to the normal force. We have newtons divided by newtons, so there are no units with that. That just tells me 61% of the normal force will become friction and oppose that motion. Now when we do this when it's accelerating, it's actually very, very similar, except that the acceleration won't be zero, and so we're going to have to keep track of all our forces. So again, we're going to draw our free body diagram that shows all the forces acting on our 50 kilogram object. We still have our 300 Newton force, and now we have Fk for kinetic friction. And of course, we still have our 490 newtons down, which is still balanced by our 490 newton normal force. So same process, but now when we go to do this and we use Newton's second law, net force equals mass times acceleration, and our acceleration is not zero. And since here, our acceleration was zero, we knew our static frictional force was 300 newtons, but now we don't know our kinetic frictional force. So we're going to go ahead and plug that into this equation. Remember, net force means sum of the forces, so 300 plus Fk is equal to mass, 50, times acceleration, and it says 0.3. Okay. So that means 300 minus the frictional force. Now I did add the negative because it is opposing my 300 Newton force, is equal to 15. So then I can add over Fk and subtract 15, and I get my Fk is equal to 285 newtons. Now had I just straight up added that, that would have been okay. I could have gone plus here, and then I'd have got my Fk is equal to negative 285 newtons, which makes sense because it is opposing my 300 Newton force. So whichever way you want to do that is okay with me. But when we go to the next step, which says Fn times the coefficient of kinetic friction is equal to Fk, this is technically a magnitude. It does not matter the direction of Fk, so we're not going to get a negative coefficient of friction. And so now my normal force hasn't changed. I still have 490. Mu k is what I'm looking for. Fk is 285 newtons, and so the coefficient of kinetic friction is 490 divided by 285, which equals, I think, about 0.58. Okay. You'll notice that this is a little bit less than our coefficient of static friction, which we expect kinetic friction is a little bit less than static friction for most surfaces.